You guys are ready, like soon we'll get started. So I'm Paul Coggin. I work here at Dynetics. I've been at Dynetics working on 15 years now. And I'm a network security architect and I specialize in designing and securing and figuring out how to break into primarily critical infrastructure networks, large networks that can't be broken into or not supposed to be broken into. We either design them and build them or, like I said, try to get into them. And so what I want to talk to you about today is, has anyone not heard about all the BGP hacks that are going on where IP prefixes are being hijacked out on the global internet? Well, what's happening there is a trust relationship out in the global internet. Whether you're running BGP or not, you're a telco service provider, whoever you pull IP internet bandwidth from is announcing your IP addresses out to the global internet through BGP. And there's an implicit trust relationship that happens up in what was the original cloud, the WAN cloud on everybody's Visio before data center clouds, so the telco cloud. Up in that cloud, there's a big trust relationship where the telcos are advertising routes to each other so that there can be end-to-end connectivity around the world. And it's very easy for someone in another part of the world or someone who owns access, either legally or they take over access to network infrastructure, to accidentally or intentionally inject somebody's routes out to the internet and possibly cause a black hole where your packets get dropped or execute a macro level, a global level man-in-the-middle attack against networks that have been strategically selected. And that got me thinking, because I built these type of networks. The networks that run BGP, in most cases, are also running MPLS. Any of you guys running MPLS circuits for your networks? Don't raise your hand, but are you running crypto? Are you encrypting those MPLS circuits? A lot of people think that they don't need to because when they go buy an MPLS connection from your telco, part of the marketing is you're buying an MPLS-VPN. And that's secure, right? Because it's VPN. It's a virtual private network. Well, so is a VLAN, so is X.25, so is a frame relay PVC and ATM PVC. Those are virtual private networks as well. They're not secure unless you're encrypting them. You're inheriting a trust relationship with your telco when you buy these MPLS circuits, and you're trusting your telco not to get hacked. Their network engineers, you're trusting them to not compromise your network when you buy these circuits if you do not add encryption to those circuits. And you're also trusting them not to accidentally fat finger a router config. Is there any router guys in here that never fat finger a router config and accidentally put in a command IP address you didn't intend to? So here's where MPLS works in the OSI model if you're not familiar with it. Across the telco's core backbone, with MPLS, it basically injects a shim, what we refer to, between layer 3 and layer 2. And you might have traffic engineering labels, the LDP label, and you may also have, depending on the which, like if you're buying circuits, you would have your VPN labels that would also be in this stack injected between layer 2 and layer 3. And the point I want you to understand is if someone can go and influence these label switched networks, and that's basically what we're doing with MPLS, multi-protocol label switching, it's label switching. We're not forwarding traffic like you do on an Ethernet switch based on Ethernet addresses, and we're not routing based on IP addresses. We're forwarding traffic based on the labels. And if you can own the label infrastructure, you can own everything above it. And so, for those of you who are not familiar, here's a PCAP of an MPLS packet that shows where between the Ethernet and the IP portion of the PCAP is the MPLS label. And you see here 3 different labels called out, label 1001, label 1002, label 1003, similar to what I showed you in the previous diagram. Could be your traffic engineering, could be the label distribution, and then the VPN for this particular circuit. Here's what a MPLS network comprises of. In the core backbone, they have routers that are called P routers, and they're just forwarding label switch traffic. And on the edge of the cloud, you have the PE routers. They might be called LSRs and LERs, label switch edge routers. I typically call them the P routers for the core backbone and the PE for the provider edge. The provider edge, the P, is where your circuits are being aggregated. If you're buying MPLS circuits, your circuits and everyone else that is buying services from that telco service provider, their services are being aggregated to these common routers. And on those same routers, they could be offering Metro Ethernet services as well as the MPLS VPNs. They could be offering internet services off those same routers. And the point I want you to get is the same gentleman, the same team, the same person who has access to these routers, that has enabled config or has access to the Juniper router, Cisco router, what have you, they have access to both the internet and to the MPLS circuits in many cases. And so whoever's compromising these BGP routes on the internet, are they also taking advantage of their access and targeting private network circuits? It could be accidental, but you have to judge that for yourself. So here's what a config would look like on a Cisco router. I don't have an example for a Juniper router. If you give me a Juniper router, I'll be glad to go ahead in my slides with a Juniper example. But this is an example of how you would go into the router and create what we call a VERF, and you would assign a route descriptor to uniquely identify the customer VPN, and you would set policies using the route target statements to import and export the VPN traffic that is of interest to you. You may only import and export traffic for the specific VPN if it's a closed customer VPN environment, but they may have a business-to-business extranet type of application where they need to integrate networks, multiple MPLS networks need to be tied together, and so you can import and export other route targets into a specific VPN if that access is needed. If whoever is programming these routers, if they were to make a mistake, they could easily accidentally import and export someone's VPN traffic that did not intend for that to happen. I'm speculating today that whoever has this access is doing this not only accidentally, but people are doing it intentionally in some cases, and we're not looking for it because nobody's talking about it. It's if you're a telco service provider engineer, or if you're someone who's pursuing CCIM, most of the books talk about this as being theoretical. I've got OC and Intel that this has actually happened to a customer. This is not purely theoretical anymore for me. So here's an example of what the routing table will look like. Any of you guys CCNA, router guys, you have access to a router, program routers for a living. You're used to going to the command prompt and doing a show IP route. You see a global routing table. You see all the routes. If you're running MPLS, or you're setting up like VERF Lite, maybe using VERF in your enterprise environment, you're going to see your global routing table when you log into the router and start doing a show IP route. But if you want to see the MPLS VPNs that are uniquely tagged by your VERF statements, you would have to go and do a show IP route, put it in VERF, and then specify the VPN that you want to look at. And if you don't do that, you will not see the other MPLS networks. They may be configured. And what happens is this allows you to virtualize the router into multiple logical routers, just like you carve up a physical server with VMware into multiple virtual servers. You can do the same thing with this router. And so everybody has a separate routing table that's configured on the network. It works great. It's kind of like ships in the night. We're all on the same router, but we don't see each other unless somebody goes in and accidentally or intentionally configures the export-import statements I was showing you earlier. Now, from the provider's edge network, from their PE routers are going to talk to each other over that core routed network comprised of the P routers, and they're going to communicate with each other using multi-protocol BGP. And they're going to advertise using the community string in BGP. They're going to advertise the route target for the policies of what traffic is associated with the VPN, what needs to be imported and exported, and based on the targets. And it's also going to advertise labels across that core network using multi-protocol BGP. And I wanted you to have, these slides are going to be available, and I want you to have a PCAP to reference this so that you can get a good understanding of what's happening. Now, So how are we going to go at a MPLS network? How are the bad guys going to go after it? Well, this is what I think about and how I consider it when I'm going after somebody's network. When I work on one of our pen test teams and we're going after critical infrastructure, we're going after a really large, complex network, I can tell you now, it's not Hollywood. It's not break out the laptop and some gee-whiz tool and you're immediately at root. I typically have figured out how to break into the target network before I ever get into the plane and get on the ground. It's figured out by doing this left side of this chart, by doing rigorous information gathering, and getting in the head of the network guys, figuring out what information is leaked, open source from LinkedIn, press releases, etc., and putting together a strategy that's going to go into the attack tree of the detailed steps. If we get this level of access, this is what we're going to do. We already know what we're going to do, step by step, what tools are going to be used, what person on the team is going to execute each specific step, and we can go and knock out a very large test very efficiently and quickly by the information gathering. But from the telco side, what we're looking at, we want to get those trust relationships. It's all about the trust relationships. Is there a trust relationship from the internet to the billing system to network management and provisioning, to is there automatic provisioning from the billing system to the network management system to turn off services and enable services based on whether you paid your bill or not? What kind of remote access the vendors have? It may not be that I can't go straight at the network, but could the adversary, because there's lots of good information on LinkedIn and your press releases, figure out what vendors you're using? It may be not the manufacturer, but maybe the system integrator. If I can figure out who you use, maybe I can go after them, fish them, pop their laptop, and then piggyback on their connection back into your secure, trusted network and exploit the core infrastructure. So here's an example. This is based on some real-world intel that I was personally involved with. This is how information leaks out. When I first came to work at Dynex, I built out a really large network. It's about 60 wide area connections. It exploded later to like 138 connections before, at the end. We were migrating a customer from one telco to a new telco, all new services, huge frame relay network. And as we did the migration, the incumbent telco vendor, they had lights out management, they provided the circuits, and they provided the routers to the customer. And as we did that migration and got to the end of that project, rolling out those 60 routers, the customer discovered that and talked to the original incumbent provider that they didn't want their equipment back. They're like, you can have it. We don't want it back. They had written it off, got all the value out of it. They didn't want their equipment. But would you believe that they left all their configs on those routers? And we're not talking about configs, username, passwords, IP addresses of their radio services back in the back office where they authenticated against, the trust relationships for the network, the SNMP, the network management protocol, trust relationships for the Telnet SSH services, all the services, the trust relationships were laid out beautifully. It is left there, left in place. And so what you could do, now, we're good guys and we had no intentions of doing anything, and we did not do anything, but what you have to realize is this is how it could go down. With that information, if we were unethical and moral type hackers, we could have used that intel to put together an attack tree to possibly go after the key infrastructure for that network. And after we've gotten some handhold, by having all that key information, we could have maybe gotten into their transport network, explored the trust relationships in the network management, and got into the transport network as the SONIC DWDM network, the routed network, and since they provide managed services to their customers, who's to say we would not have been able to pivot down to edge customer networks? What you get, when you're buying these services, you're inheriting a trust relationship. It's your responsibility to secure that trust relationship and not just assume because it's a magic WAN cloud in your Visio that everything's okay. You don't know if the people you're buying services from are practicing good OPSEC. In this case, there is no OPSEC. Here's what an example of what we call a monolithic architecture would look like, a single provider MPLS network, where this is a single telco, and this is what their infrastructure may look like, where they go out to the global internet, they have their internet backbone, and then they have you drop down into their infrastructure for their core MPLS network. And then you look at the bottom and you see the services that a customer may be providing at the edge of the network, where they may be buying internet and MPLS circuits and terminating that, in some cases, to the same router. They may be purely a spoke site with just an MPLS circuit. But what if the network engineer in this cloud, with this telco, what if they're compromised? What if they get turned and start working for the other team? What if they go rogue? And there's plenty of public OSINT examples of where network telco guys have gone bad and started doing things in networks. So what could they do? Or maybe the network gets hacked. Maybe somebody remotely gains access to that network infrastructure. What are they going to be able to do? Well, maybe they're going to start adding new networks, new MPLS-VPNs to the network, and linking that new network into other customer networks. Maybe they just configure a circuit to join your existing VPN, and they look just like they're part of your normal VPN. It's just they're an additional circuit, and there's nothing to stop them from associating that with an internet VPN type circuit, like a GRE circuit that's popped out over an internet connection to somewhere else in the world. And they associate it with your MPLS VPN, and they're doing MPLS with you. Maybe they go and use lawful intercept, where you and I may be talking, but a perfect copy of our PCAP traffic is sent to another destination. Or use an ER span, where you can push, where you guys are familiar with span port mirroring. Well, with ER span, you can mirror a connection over a wide area network. Why can't they? If they got access to Coggin, you may more likely catch an ER span type exfil quicker, because it's going to pull all the data. But who's to say what kind of backdoor they may put in to get your traffic? And I can tell you this scenario right here, OSINT intel that's confirmed that this is already happening. It's happening in the U.S. It's not foreign. It's happening in the U.S. to a network. If you're not encrypting and securing your trust relationships, somebody might be helping you out with your network. They may be in your data, compromising your confidentiality and your integrity, or they may have pivoted deeper into your network and have greater access. If you're not looking, how do you not know? So here's a more complex scenario that I was expecting to hear about compromises in the future, where you have a carrier that is going to establish a business relationship, a peering connection to another carrier that would in turn maybe establish yet an additional peer-to-peer network exchange point. We get another carrier, and this would happen like internationally, where you may be dropping out MPLS circuits in Asia from the U.S., South America, where your connections may have to go across multiple telcos. Now you're going to go buy circuits from one telco, but you don't know on the back end all the different peering agreements that they have set up for BGP and MPLS. And you may have a really good telco that's doing your local loop service and building your cloud in the U.S. But when you start going overseas, you may not know all of the agreements and who all has agreements set up and dropping out your circuits, and who may be going and packet capturing, maybe injecting new routes into your network. Who knows? It could be any number of different attacks. And one of the things I wanted to call out with this slide, make you aware of, is in the books that I've read, what's been published, it was theoretical, very complicated, not likely. It wasn't explained if it was possible how you would do it to go and gain intel on labeled IP prefix mappings in an MPLS network, in these core networks, where the traffic is traversing from between the PE routers and the P routers, across those core backbones, how somebody may go in, a bad guy go in and hack that network and try to identify the traffic that they're interested in, so that they can execute a surgical strike against it. Well, I started thinking about it. It bothered me that they didn't explain it and they kind of left it out there in a theoretical land. Well, here's some ways that I would go and attack that. If I wanted to go and map out, if I got into a large telco and I knew that your traffic was traversing it, but I didn't know exactly what MPLS-VPN you were in. One way that I might go and try to exfil traffic, where I could go and reverse engineer it offline to find out what MPLS-VPN I specifically need to target. One way might be to use ER-span. Or possibly use the lawful intercept. That might be a way to get that traffic and for offline analysis. And if I'm a nation state coming after you, if I'm tied to organized crime and I have the funds, if the network is traversing through my infrastructure and I have control, it doesn't matter that ER-span may be not the cleanest way to do it. I got the money, I've got the data, I got the resources, I control the pipes, I'll mirror off as much as I can take. And then offline analyze it and be able to map that. It's something that you need to be aware of. Again, you've got to have this end-to-end encryption. Another thing to think about with MPLS, one of the techniques that you can use to balance out in your network so that you're optimizing your transport network infrastructure so that traffic doesn't utilize one portion of the network more than the other, so it's all balanced out more. You're maximizing your investment in fiber, undersea fiber, however your network architecture is. We use a technique called traffic engineering to better engineer how our traffic flows to maximize the infrastructure. And we also use it so that over a fiber network with no TDM infrastructure underneath, basically SONET, or if you're outside the U.S., SDH is the equivalent of SONET, say in Europe and Asia. You want that 50 millisecond failover that you can get with SONET. Well, we can use traffic engineering, and you can get it with IP, what we call IP over glass, IP over Ethernet, over fiber. We can go and get that same level of failover. And that's one way we use traffic engineering for good things. And a feature that's not good or bad that you might not be aware of, but it could be used against you if you're used to, on your MPLS network, being able to go do trace routes and see how your traffic is traversing through your carrier. Well, one thing that you can do with traffic engineering capability, there's nothing to stop a telco from turning off the IP TTL and hiding your router hops as you traverse over the MPLS network. And if I start hiding the router hops, you have no idea how large a network and how many hops and where in the world you may have traversed before you got to your endpoints by just turning off the TTL. And what that could do is I could swing traffic around different exchange points where I may have the infrastructure to do a full PCAP mirror and capture the traffic and then send it right on down the line at layer 2. And the only way you would know that something like that's happened is if you have telemetry data and you've previously measured in baseline your performance end-to-end of your network. And if somebody does that, you would only be able to tell by the timing of your packets. And you can't hide the physics of time. There would be that. You wouldn't see the logical, you wouldn't see a change in your layer 2, layer 3, but you would notice it based on time. So here's some thoughts. If you're not looking at your BGP, if you're not looking at if you have BGP, or if you've got an internet connection, everybody in the room has an internet connection. If you're not proactively monitoring your IP prefixes and seeing what's happening with it out on the web, how do you know that someone is not hijacking your routes? Most likely, just like most people have malware in their network, they just haven't discovered it. I'm speculating that most likely, especially if you have anything with value, if you're in a business that you know you're being targeted or susceptible to being targeted, they're most likely are hijacking your BGP routes as well. It's just a lot of people are not looking. Everyone is talking about it in the web. You know, there's the Bitcoin recently, Facebook, YouTube. Why not do it? Why? And so what I recommend is you go and visit the BGP Mon site, visit the Team Cumry site, maybe go look at Renesas, or they provide services to proactively monitor and alert you based on IP prefix changes. And maybe take it a step further. Why not go and monitor the IP prefixes of your business peers, the people you do business with? Maybe monitor the IP prefixes of your competitive peers. Maybe you could get some intel if your peers are being targeted, if their IP addresses are being hijacked. Maybe they've already hit you and you didn't catch it, or you may be next on the list. There's nothing illegal about going and putting IP addresses out and monitoring to see what's happening proactively. If you have a staff that is skilled with scripting, if you have a Python engine on staff, you can go out to the BGP looking glass sites where all this information is freely available of what's happening with the global internet. Network engineers that work with BGP live in the looking glass servers and hopping around the world to look at their IP prefixes to see how their routes look to the rest of the world so that they can configure and tune their BGP to balance out their network traffic. It is a really good place if you're doing information gathering for you guys that are CEHs, ECSA guys this week. It's a really good place to go get intel to see on your customers that you're targeting. But it's also a good way to go and monitor your networks to see if things have changed about how the global internet views your IP prefixes. And you can set up and automate that so that it happens proactively without subscribing to one of these services. But you need to be doing something. Now, on the MPLS side, here's some recommendations I have. You've got to get visibility. You have to have secure visualization and instrumentation on these networks. If you're a non-Cisco shop, you need S-Flow. If you're a Cisco shop, use NetFlow. Know what is normal. Baseline your traffic. Get that statistical telemetry data. Who should be talking to who, when, where, why, and how much. What is happening there. Get that intel. And be monitoring, especially with the MPLS networks, what is flowing in from your external wide area network, and be able to know if someone is injecting new routes in your network. Be logging, look at your routers, and know what routes should be in your network, and proactively monitor your network to know if you're seeing new IP prefixes injected into your network. Maybe it's your IP prefixes that you own, but the metrics are changing. Maybe I'm hijacking your IP prefix, not only am I in your MPLS network, but I'm introducing IP prefixes from your network from a different point. I don't know. You need to monitor your network to know whether that's happening to you or not. And I recommend, to take it a step further, access lists are free. You pay for it, whether you have the Juniper Cisco router. Why not use them? Know who should be talking to who, when, where, and how much, and use access lists to lock down those trust relationships. And if anything violates those trust relationships or protocols, advertising routes into your network, log it and flag it and run it to ground to know what is violating your trust relationship. Is there new networks that have been added? Is there a new branch location that have been added to the network? Is there new data centers and new VLANs that have been added? Why are we seeing these new routes? And why are they popping up from this location? Can you today, if you have a network that has anything other than a static route going out to one internet provider, if there's changes in your routing table, would you know it? Ask yourself that. Are you collecting the logs to know what is normal, and you have that baseline? The other thing is, if you're not using two-factor authentication, it's minimal for your network infrastructure. You need to start there and move your way down between your VPNs and your network infrastructure, because I'm coming after your passwords, I'm going to get your passwords, and I'm going to log into every piece of network infrastructure you have. It will be very, very frustrating for me if you're using two-factor authentication. And be careful about using two-factor authentication depending on your phone. The malware guys like Amir have figured out how to go and hijack your two-factor authentication is leaning on SMS. They can pop your phone with malware and maybe send off that second piece of information of your two-factor off to them so that they can log into your equipment. I prefer a hardware token provider, something that will give you, like those secure ID key fobs. I want to separate. Here's some references if you're new to BGP and MPLS. Here's some references. If you've not read Scott's book on IPv6 security, not only does he give you a really strong overview of IPv6, and the critical information you need to know to secure your network, whether you're using IPv6 or not. But it gives you some really good insight into how to secure your routers. That's what I have to share with you today. I don't think we're running tight yet. Is there any questions? No questions? Well, if you want to talk afterwards, I'll be around the rest of the day. I'll be glad to talk to you. Thank you.
Well, I think it's a first that Paul got through early. So our next speaker is not scheduled until 10 till. So you guys, we get set up.